properties of equality give us two basic moves that we can use in solving equations. The additive property tells us that without changing the solution set, we can add the same number to each side of an equation. And of course, because subtraction is just adding the opposite, we can also subtract the same number. The multiplicative property tells us that we can multiply by the same number on each side of an equation. And of course, because dividing is just multiplying by the inverse, we can also divide by the same number on each side. Now, notice that there was a complication in the multiplicative property of equality. We can add any number, so it's safe to add variable expressions. However, we have to be careful to never multiply both sides of an equation by 0. So when we're considering these basic moves, we're going to avoid that entirely by just never multiplying by a variable expression. And of course, we certainly can't divide by 0. No good would come of that. We are going to eventually find ways to eliminate variable terms and to multiply by variable terms, but it requires extra cautions. And so for that reason, when we're thinking about our basic equation solving moves, we can add and subtract anything we like, but we can only multiply or divide by constant numbers, things without variables in them. Okay, let's just solve some equations just to review what this process looks like. We'll solve 2x minus 3 equals 7, which is a pretty straightforward equation. The first thing I want to do is get rid of that minus 3. The opposite of subtracting 3 is adding 3. So the first thing I'm going to do is add 3 to both sides. And when I'm working with an equation like this one that contains really easy to work with numbers, I'm typically just going to write down the result of that step. So I'm just going to write 2x equals 7 plus 3 is 10. And essentially the reason that I'm not writing anything to indicate that little plus 3 is that at a certain point, indicating really simple steps is just kind of cluttering up your work, right? At this point, we all know that adding 3 to both sides is a legal move. We can look at this and see that 10 came from 7 plus 3. We don't really need to write anything to indicate that. You are welcome to write something to indicate that you're adding 3 to both sides if you find it helpful in keeping track of what you're doing. Otherwise, for simple things like this, it's okay to just write the results of the step. This is typically what I'll do for simple steps like this when I'm demonstrating problems. Okay, so now I have 2 times x is 10. Now I want to get rid of the 2. They're multiplied together, so I need to divide. And again, I'm just going to write down the result. X is 10 divided by 2 is 5. So x equals 5 is the solution to our equation. And we see that that really does work, right? 2 times 5 minus 3, that's 10 minus 3, really is 7. So x equals 5 really does make this equation true. And the fact that we used our basic solving moves to solve this equation tells us that 5 should be the one and only solution. Let's see a slightly more complicated equation to solve. Here we have the variable appearing on both sides. So the first thing we need to do is to eliminate the variable on one side. And I'm basically always going to just eliminate the variable on the right. So I'm going to collect all my variables on the left, and in this case, all my numbers on the right. The first thing we're going to want to do then is to subtract 2x on both sides. That's going to combine with this 5x term, and we'll end up with 3x minus 7 equals 5. Okay, now this is the same kind of equation as the previous one. Next, we'll want to get rid of that minus 7, so we'll add 7 to both sides. On the left, we're just left with the 3x. On the right, 5 plus 7 is 12. Finally, we want to get rid of the 3, so we're going to divide both sides by 3. So on the left, we just have x. On the right, 12 divided by 3 is 4. And again, we can confirm that that really works, right? 5 times 4 minus 7. That's 20 minus 7 is 13. 2 times 4 plus 5, that's 8 plus 5 is also 13. Right, both sides of our equation work out to the same number. That's really the solution to the equation. And because we used only those basic steps, we're sure that that's the only solution. Okay, one more. This equation has fractions in it. And you might have seen a step where you clear out the fractions. Sometimes that's valuable, but it's the 21st century. We have calculators that can do fraction arithmetic. If we're just looking for the solution to an equation in one variable, it's not necessary to clear out the denominators. We can just solve this equation just exactly the same way we did the previous example. Notice when I copied that equation, I was careful not to let my variable creep into the denominators of these fractions here, right? Your variable needs to very clearly not be in the denominator of your fraction if you have a fractional coefficient, because your variable being in the denominator would make it a completely different and altogether more unpleasant equation. Okay, so here I have arithmetic I can't necessarily do in my head. So here I am going to write indications of what steps I'm doing. First, I want to get rid of this 1/6 x. So I'm going to subtract 1/6 x on both sides. 2/3 minus 1/6. You can ask a calculator for this if you like. We'll have 1/2 x minus 3/5. And on the right, all that's left is 4/5. Okay. Next, I need to get rid of this minus 3/5. So I'll add 3/5 to both sides. 1/2 x equals 7/5. And then the last thing I want to do is get rid of that 1/2. I can think of this as dividing by a half if I want to, but I think it's easier in this case to think of it as multiplying by 2. And I get x equals 14/5. Right, so what did we do? We subtracted 1/6 x on both sides. We added 3/5 on both sides. And finally, we multiplied both sides by 2 to get x equals 14/5. Now, when I go to plug this in to make sure that it worked correctly, this is another job for the calculator. So I'm going to take 2/3 times 14/5 minus 3/5. I'm going to take 1/6 times 14/5 plus 4/5. I'm going to work both of those out on a calculator. And for the left side, I get 19/5, or excuse me, 19/15. And for the right side, I also get 19/15. Right, notice before I worked out the arithmetic by hand following order of operations. This arithmetic was a little bit less pleasant, so I just threw the whole thing into my calculator at once. And I saw that both of them give me the same 19/15.